Okay, great. All right. Well, thank you for inviting me to do this. I wish I could be there in person. It's kind of surreal, I would say, from my perspective, to see this room and all of the discussions that are happening. I don't know. It's very fun. So, I mean, this is going to be a different kind of talk. It said a decade of HistFactory. While writing it, realizes it's getting closer to 15 years than a decade, which is also kind of crazy and maybe reflected in the gray in my beard now. So I started to write an introduction, and I thought I'd make a funny picture, and then I just decided to use that as my introduction. So my prompt for myself for writing this talk was to create a sort of lighthearted talk of a middle-aged physicist walking down memory lane, and include computers, equations, and the Large Hadron Collider, and make a few observations or hopefully somewhat insightful points, and then try to end with something inspiring. So anyways, I hope you're not expecting too much, and this is more just almost more like entertainment than anything else, but okay, we can chat later. And apologies that, it is a little bit, this is from my perspective, right? So, anyways, so this, some of these things are queuing up points that I want to make later. So one thing is, I'll just say that, like, when I first arrived at CERN in 1999 and LEP was still going, I was kind of interested in data analysis, but was not yet like a statsy person, really. There was a problem that people were facing, which had to do with the fact that the histograms that people were using to stick into the statistical procedures for, like, the LEP-Higgs combination, where you can see the histograms are noisy because the binning is fine and there's a lack of Monte Carlo statistics, and so they wanted something smoother. And so I started developing an approach based on kernel density estimation on that. Also kind of interesting in this is, like, there are already neural network outputs. So this is, a while back, we were using neural networks and things, a lot of similar issues. I remember I met with Fred James, who was the author of Minui and Minos, and was also used to be the editor of the computer physics communications for many years. I talked about publishing this, was my first paper, and I remember, kind of funny, him making this point that I should be careful about specializing in sort of statistics. Oh, that got cut off, and software things. So maybe that's still true. Maybe things have evolved. I'll leave it to you to decide. But it is a little bit funny. I did write some code at this point. I was not much of a software engineer at the time. It was in Perl, and it used PA, which is like the predecessor of root, if that gives you some feeling for where things were. But it was kind of interesting in that, somewhat similar to HistFactory, it was designed so that a lot of people could come together providing different sources of information, which would be, files that had a bunch of events in them, and you would have a little configuration file that told you where to go find those ingredients. And then it had a recipe that would take them and then produce some output. In this case, the kind of smooth distributions. That's actually that code. If you have any desire to see some ugly Perl code, is sitting in this DOI, which is also kind of interesting because it was one of the very first software DOIs minted with GitHub and Zenodo. So this is like 1999. I did have the pleasure of getting to join this first workshop on confidence limits, which is effectively the first PhiStat meeting, which I think many people in the room are kind of familiar with. There's a picture of Louis, just because he was a big, he sort of suggested I work on some projects early on, which were things that ended up being very influential for me. But it was at that meeting that there was this kind of famous discussion about publishing likelihoods and everyone agreeing. Of course, it took quite a while for that to happen. Now, a few years later, around 2003, 2005, was focusing on basically how to forward evolve things that had been done at LEP and things that had been done at the Tevatron for the LHC. And that was both on the kind of statistical methodology side and also on the software tools. I should say that at the time of LEP, when they wanted to do a combination, it was all written basically in Fortran, and they had to get all the ingredients from the different analyses from the 4 different collaborations, and then compile the whole thing into one big executable. So, like, you can imagine how hard that was to do. There were like no interfaces. It was really at the level of like source code. So I was looking for something like, looser. It was after this PhiStat 2005 that Rene Brun approached me about trying to organize some kind of something for statistics inside of root that went beyond things like t-limit and stuff like that. ROOFIT was already being developed at Babar and had was a very attractive, but it wasn't clear if we should base it on ROOFIT at first or not. And then after doing some whatever exploratory stuff, we decided to move forward and base roostats on top of ROOFIT. I'll say that some of the design principles that are still relevant now, and you saw them mentioned in some of the talks earlier, is that a lot of these tools mix together lots of different things. So you had the kind of the late stages of analysis, the building of like histograms or et cetera, the statistical modeling, then the actual statistical inference part, including if you're Bayesian or frequentist, how you deal with nuisance parameters, do you marginalize them or whatever. All of these choices were all kind of encoded into one big blob and some kind of overarching framework. And with roostats, I really wanted to try to separate that, because at the LHC, there was no agreement on what the statistical procedures would be. And so we wanted something flexible and wanted to be able to compare across the different methods, but have the same statistical model. So it's kind of obvious now, but at the time it was kind of a big shift. And it is kind of interesting because there's still a lot of that still is happening, right? So then, I don't know, 2007 was kind of the beginning of like ROOFIT and roostats. Around that time was when we also realized that we could actually write out these statistical models to a file with the workspace using like Root's persistence technology. And so that was an interesting development. And then you just see these things from kind of 2008 when we were first like adding all the stuff to Root. This is one of these slides I show with the very first kind of examples of using a workspace. And an important thing here, which I think this crowd knows, is that it wasn't just publishing likelihoods, it was publishing the full statistical model, because you needed to also be able to generate toys if you wanted to be able to do like frequentist statistics, or if you had like small bin counts and things like that. Now, this next thing has nothing to do really with pyhf, but it is, directly, but it is important, is that around this time, I was also working on some analysis framework for Atlas, which was called EventView. And it was, at the time, the experiment wanted the analysis to be done within the Athena framework. And so we were developing this analysis framework there. And it was really kind of a cool framework. It was very modular, it had all sorts of nice features about it, but at the time, the LHC hadn't started yet, and a lot of people were happy with it, but there were just a lot of people, like a third to a half of the collaboration, that essentially just didn't want any kind of framework. They wanted to roll their own thing, and they just didn't like to be kind of confined or bought into some framework. So this whole project ended up being essentially abandoned right before turn on, essentially in for some vaporware that never really showed up. Personally, on a personal note, it was a terrible experience. Lots of ulcer-inducing, stress. But anyways, that's what happened. But as a kind of somewhat in reaction to that, I was also working on like statistics tools, largely in the context of TOP, and it was that kind of learning lesson about people not wanting to be kind of confined to some, big, huge monolithic framework that led to a lot of design decisions around HistFactory. So in particular, the idea was, okay, we want to do one specific thing. We want to build a statistical model that we're going to then later hand off to roostats. And the way that we're going to build the model is going to be according to some, fairly agreeable set of rules, which is, what we now call the HistFactory specification. It took a while to kind of flesh out all those rules. But then the idea was that all the people that are providing an individual histogram or a different systematic variation could in principle do their work totally independently, make no assumptions about how they do it. And all they have to do is show up, with a shared file system that has a bunch of root files with histograms in it. And that was the only level of coupling that we had between all the people that are coming in as input to HistFactory. So in that sense, it did have some similarities to that keys, like kernel estimation project that I mentioned before. And we weren't really talking about declarative specifications as a language at that point, but certainly that was what was happening. Just to kind of highlight some things, this was kind of 2009. We were developing this initially for the first TT bar cross section. Akira Shibata, who was involved in that event view project, was also one of the early developers of HistFactory. He moved on from physics, and just incidentally yesterday on Facebook, he posted this thing where he's interviewing Guido, which is pretty cool. Anyway, so he now works for Weights and Biases in Japan and is having a cool career. But anyways, I thought that was kind of funny. This was the first paper that used HistFactory. Again, it was, we were at 7 TeV, 3 inverse picobarns of data. So, that's pretty crazy, small amount of data. This was written during Thanksgiving, and I'll just say that it was not relaxing Thanksgiving. All of this then kind of got carried over into the Higgs stuff. So around 2011, there was a big push to start using it in that context. We had to do a major rewrite of HistFactory because it was like, it used to have a Poisson distribution for every bin of a histogram. And so that was computationally very slow. And so we kind of totally redesigned it at some point, but we were able to keep the same specification, which was nice. And then, well, I think everyone knows, we had the Higgs discovery, all of this kind of workspace stuff, and the ability to be able to work in a much more loosely coupled way was very successful in allowing us to combine, hundreds of different, data sets and different kinds of analysis components together for the Higgs discovery. And so that, and the complexity of the models just exploded. So that was all cool. Also around 2012, there were the first kinds of, discussions that while there had been a big push to separate out the modeling from the statistics or how you build the models in the first place, there were people in the user community that liked that kind of integrated, kind of streamlined user experience, which is the kind of thing that we kind of purposely were fighting against for a little bit there. And so that was when we first saw things like HistFitter get going. To some extent, what was happening in CMS was somewhat a parallel development where you had people that were happy to be using the RuStats tools and the RuFit interface and all these things, but they also wanted a kind of top level, user experience to be able to drive all of the things in some kind of nice integrated way. So again, yeah, this was around 2012. Also around 2012, which I thought was pretty cool. I remember this meeting in building 32 was just a few of us, but I had recently learned about automatic differentiation, and I was it blew my mind, and so I was trying to convince the team that we should try to incorporate autodiff into RuFit and things. So that was back in 2012. It was a lot of work at the time. There were not the sets of the kinds of tools that we have now, but it is kind of interesting to see how that's continued on and flourished recently. Okay, obviously we discovered the Higgs. That was exciting. Shortly after the Higgs, we were then trying to understand its properties and look into it into more detail. And so you get into a lot of property measurements and things. I will say that the fact that we were able to pivot so quickly from discovery mode to measuring properties was largely due to the fact that the likelihood models allowed us to reparameterize them. So when people were building the models, they were just thinking discovery. And so there was some foresight in how we built the models so that we had the right handles to be able to change production cross sections and branching ratios and these kinds of things. But it was certainly, we moved very quickly, and that was cool. So this was one of the early papers that Atlas put out about some property measurements. And when people took the information that was in the papers and they tried to reproduce it, they would get results like this yellow and green contour, which don't agree with the published results at all. And so this was a problem because we just weren't giving enough information. There was a big push around 2012 to try to think about the reinterpretation and things like that, and there was a push for public likelihoods back then. So Sabina, who's has always been a champion of that, along with a number of other people. And then We had, some meetings at CERN trying to push forward on this. As of 2012, again, at 2013. Later that year, we were able to get Atlas to not publish the full statistical models, which technically was doable. It just wasn't, sociologically acceptable yet. But we did get Atlas to publish essentially profile likelihood scans. So these would be, it was a smart choice about what parameters to scan. So instead of using things like these previous results, which are like kappa V and kappa F, are very like, model specific, we moved to things that were much more phenomenologically relevant, like, scale factors for production cross sections and branching ratios, and broken down by different decay modes. So this allowed you to do all sorts of nice things. So you could take these results and combine them together, and you could reinterpret them and do things like the kappa V, kappa F via reparametrization, and they would agree very well with the results and the published results. So this was a pretty big step forward, but we still weren't providing the full likelihood, and we weren't providing the full statistical model, so you couldn't do toys or anything. And as was discussed in the chat just a few minutes ago, these were all profiled individually. So if you try to combine them, you would get some inconsistencies, and you could tell those differences. Around the same time was the big push that was going on around recast. It wasn't the narrative at the time about how the likelihood publishing and the recast were really part of the same vision. That kind of came later, but it was always there. And here's like some funny figure I made back in 2012, which was basically like, okay, you want to reinterpret your things, you need a statistical model. Do you already have, have you already run that signal through it, and you have like the published likelihood? If so, in XML, you can go ahead and like do it. If not, you can run it through recast and get what you want. And it took a long time and a lot of hard work by a lot of people to get to where we are. But it's just cool to see that we got there. So then from like, I don't know, a few years after that, around 2013 to 15, that's, deep learning was starting to really take over. I started thinking about like simulation-based inference stuff. Recast was going. We had this workshop at CERN, which is the data science at LHC workshop. And I don't know who was there, but one interesting thing that happened was that TensorFlow was announced that day. So that was like just kind of funny that happened at that same day. Also around that time is when, in the US at least, we got this pretty big grant from the National Science Foundation for HEP, which later grew into IRIS-HEP. And that was one of the things that started to help fund some of this kind of research, at least in the US. So, a little bit later, as a kind of, IRIS, in sort of laying the groundwork for IRIS-HEP, we had these workshops. And I remember at one of these workshops, we were talking about how it would be great to kind of rewrite our statistical stuff and start to use these machine learning frameworks and autodiff and big computational graphs and things like that. There were a few different ideas that were starting. So Gilles Loup and I were working on this Carl package. Igor Babushkin, who's was at DeepMind, now is I think leading sort of XAI, had developed this TensorProb as a kind of like exploratory project. Matthew Fikert became Diana Fellow to start working on what became pyhf. And anyways, I would say the rest is history, except I have some more slides. Anyway, so that was pretty exciting. It clearly matured quite a bit. Initially, it was mainly Matthew, Jordan, and Lucas as the kind of core team. What's great about the project is it's become really a community effort. And so there's a lot of contributors now. It was doing a lot of, I think, just as a project independent of the software, just great to see the leadership and things like community building, the Journal of Open Source Software, now the connection with NumFocus. This is all, of course, happening not just pyhf, but within the broader kind of scikit-HEP and pyhep community. And it's such a big change from how the attitudes around software were, 15 years ago. And so I think it's, for the positive, and it's great to see. I think now, of course, everybody knows about some of the rest of this, like it was just, but in terms of milestones, it was like January, the beginning, essentially not January 1st, but almost, there was like the CERN had this kind of on the homepage was highlighting the fact that we were starting to publish likelihoods, which was cool. There was then this big push for this community, white paper to kind of call on the experiments to keep publishing statistical models. Now you see things like the Atlas results page. You can filter results by which ones have the likelihood. You see this being incorporated into HEP data, which is fantastic. We see tools like cabinetry, which have been around. That essentially, the revived version of things like HistFitter and T-Rex fitter, but really make it so easy to take these results that are on HEP data and then within just a few lines of code be able to reuse them and make new kinds of plots. So this is great. And then these tools are being then incorporated into a whole like ecosystem that's emerging with tools like, the Hist Explorer that Abe showed and the Workspace Explorer that Volker showed, and the S models interfaces and things that Sabina and Jack were just talking about. And so it's just wonderful to see, all of this flourishing. And I'm just kind of try to wrap, of course, the fact that we have this declarative specification and there's like the initial, kind of reference implementation and root and C++, and then in the, Python with various backends, and now also the kind of Julia versions of them, this is all, again, a testimony to this kind of concept of using a declarative specification, which is great to see. When you think about that, the part of the reason that it worked well with pyhf initially is because we were working not so much because they were binned, but because the models were more closed world. They had a specific specification they were trying to conform to, and working with more open world models, which usually people are thinking about unbinned ones. But again, it's not really the unbinned, it's the fact that there's just such a variety of different kinds of modeling components has been a bit of a challenge. But now there's this kind of very promising effort, HS3, to try to serialize these things and try to kind of have specifications for each of those components. And I think this is, again, great progress. So, yeah, I'm sorry. I was just kind of just trying to celebrate lots of the great things that have been going on. I mean, I think the other one that was really cool was in the move to try to incorporate auto diff, not just into the fitting, but into the whole analysis pipeline. There was this cool work from Nathan and company about NEOS and then to where you actually now are differentiating through the statistical procedure itself, and that requires some higher order notions around autodiff, which is pretty cool. And then we see these kinds of extensions of pyhf, for instance, for EFT fits. It's already very well, got a very well established relationship inside of the kind of BSM, reinterpretation world, but it's nice to see it extending into things like EFT fits. And to do that, it's going to require kind of going beyond the kind of core HistFactory specification. And so thinking about some kind of plugin type of ecosystem there, I think is interesting. And we're starting to see that. And then, of course, there's this workshop itself, which is a big milestone. Again, I think it's cool that not only is non-focus helping support it financially, but just that we have that connection. So applauds to the group for making that happen. And then I'll end with kind of what's next, and just one slide, which is that over the last few years we made a big push to develop community white papers, like through the SNOMAS process, talking about the importance of these kinds of things. A lot of this was then captured in the SNOMAS recommendations that led to the as input to the P5 report. That's something that I've been busy with for the last year. But we are basically done with that now, and the report is being on Thursday. So I definitely encourage people to go check that out if possible. In addition to thinking about all the big experiments and projects, I would keep an eye out for things around software and cyber infrastructure and these kinds of topics of reinterpretation, etc. See what there is to say there. But anyways. That's it. And so in conclusion, I don't know, for me, and I think for everybody, it's just kind of amazing to see how much all of this has moved forward. And of course, it's only possible due to the shared vision and the hard work of the community. So I guess to just end with saying, keep up the great work.
Thank you, Kyle. That was a super talk. And yeah, it's, I think, kind of a special treat for this workshop to, you know, have someone who's been part of this from the, you know, day zero to kind of share that perspective. So maybe we can, you have one other short talk, so maybe we can take a few minutes for any questions and then we can go to that. But I see Alex already has a hand raised. So Alex.
Yeah, thanks. I think this was like super interesting to see this perspective. You're mentioning how in 2012 you're excited about Autodiff and sort of like thinking about using it. So what's the thing in 23 to be excited about that we should look into now?
Yeah, good question. Well, I mean, I guess there's maybe two parts to that. I mean, one is that I was going to add some slides, but it was going to take too long. But for a long time, we had, you know, the way that HistFactory parameterizes the effective nuisance parameters with kind of one at a time is definitely not, you know, it makes a lot of approximations, and it's something that for a long time has been on the radar of things that we could improve. There was a little bit of prototyping about how you would, if you wanted to kind of sort of arbitrarily scan through the nuisance parameter space and get off diagonal elements and things like that to improve the quality of the systematics modeling, how we might do that. And I think one promising approach is to use Gaussian processes as the way of, you know, modeling the response of like what the expected bin count is as a function of the nuisance parameters. There's been some somewhat related work that did with Sid Mishra Sharma in the context of astrophysics, where it was again bin Poisson with some kind of uncertain background, and we did use Gaussian processes there. There it's, you know, on a sphere because of the sky instead of a standard binning. But I think that's one area where we could definitely improve things, and it would help a lot. I mean, the other kind of high level version, I think, is a bit of a, you know, is this kind of essentially the simulation based inference approach where we think about how do we, I mean, one approach is the kind of NEOS thing where you say, we're going to still use bin likelihoods, and we're going to go, you know, include all of our systematics and go to the final result and try to optimize the analysis that way. And that is one approach, but the likelihood is still multiplicative. And I do still believe that you don't necessarily have to optimize the whole analysis if you can do a good job of understanding the per event likelihood. And I think the simulation based inference approach is kind of along that direction, but there's a spectrum, right, between how much does it look like what we're doing now versus the kind of fully blown, you know, Mad Miner style thing. So that's not really that's not technical at the level of Autodiff, but I guess those are still, I think, the things where we have a lot to gain. And then there's just, I mean, the other part is that we still don't really do as much as we could in terms of approaching the analyses with a kind of slightly reoriented mindset where we think, okay, we're going to do our best to model this region of phase space, that region of phase space, that region of phase space. We're going to work to make sure they're all exclusive regions so that we can combine them together, and then just have a kind of recast, reinterpretation, combination mentality from the very beginning. If we did that, I think that's the ultimate approach for trying to get the most out of the LHC data. But I don't know if I'm answering your question, but.
Yeah, I think so. Thanks.
Okay.
Jordan has a question as well, and then we should probably, after that, move on to to Kyle's second talk.
Yeah, the other one's very
Hi,
short.
Kyle. So I always seem to learn something new about things you've done in the past every time you give a talk. I guess I wanted to ask more on the restart side of things. Given that you were kind of there from the beginning, is there anything you would have done differently back then?
Yeah, good question. Well, I mean, yeah, at the beginning, I will say that like it was kind of interesting. There was a lot of the emphasis at first was not on the software part. It was really about, a lot, I wouldn't say arguments, but debates about like, are we going to be Bayesian or frequentist, and what statistical models we were going to do? And, asymptotics still were not established. So, people complain about these fits being slow, but we used to spend like, 100,000 CPU hours to generate toys for every point. So it was like, what people call slow now is like lightning fast. But the pressure of dealing with that led to, kind of forced us into what turned out to be some good design decisions, and I think that separating out all of those different pieces was useful. In terms of what would we have done differently, I guess the main thing is that if we would have had more person power on the tooling, we definitely had a lot of ambitions for things that would have been really cool. But we were super strapped. We got 0 credit within the collaborations for any of this work, and it was almost impossible to get any funding for it. So I guess the main thing, and we did try to get money for it. If we could have somehow thrown in more effort, and then we also didn't do a great job of documentation. Documentation was kind of terrible. And so, it led to kind of somewhat of an othering. There was like a small group of people that like knew how everything worked, and then a lot of user community that kind of had to trust them. So I think that some of the things that are happening now are improving on what we did then in terms of how the community is being engaged. So that's definitely something I would have done differently if we could have, but we were strapped for resources, and I think I'm very happy to see what's going on now.